Our first presenter in the vendor section is Neville Glanville. Neville is the Industry Sales Director for Building UK, Ireland, France and Iberia. He's very active since 1980. He started with mainframe computers, and you believe that it's time for BIM. So we're looking forward to hearing what you have to say. Thank you very much.
Okay, thanks Alan. Yeah, good morning. I'm Neville Glanville. I'm the Industry Sales Director for Building. I just want to spend my 20 minutes talking about some of our technology, and I agree with Alan. Technology is important, but it's BIM is more about process and people, but technology plays a very key role. So I just want to share with you today some solutions for BIM from Bentley. So I'm going to talk about a new product to start with, but then I want to go on to the subject of BIM holistically. And share some thoughts from Bentley's perspective on what BIM really is and how we embrace the entire life cycle. One of the discussions we had on our table was that I raised the point that BIM to date has largely focused on design end of the business, but actually it should be addressing the whole life cycle, and particularly the greatest beneficiary of BIM as a process is the client ultimately. Bentley Systems are looking at, in terms of developing that technology, it's all about providing integrated solutions. So from a building perspective, this is not just about design, it's about design, construction, and day-to-day operations of facilities. And I just want to spend a few moments today talking about our new product, EcoSim Building Designer. EcoSim Building Design is essentially providing all of the four main design disciplines in one application. So that's architecture, structural engineering, mechanical and electrical. It's all available as an integrated design application called the EcoSim Building Designer. There are two sister applications. One is Energy Simulator, which is focusing on the building performance, looking at analysing and simulating the building performance, linking through to other simulation tools. And then Compliance Manager in terms of LEED accreditation. We're working on BREEAM accreditation and so on. But that's an important factor moving through. Just touching briefly on the individual disciplines. So the architectural flavour within the application is very much focused on three-dimensional design, but two-dimensional output. And 2D, the perception exists that BIM is all about 3D. From our perspective, absolutely it's not the case. It's really important that we have two-dimensional tools, very powerful capability for producing details and other 2D documentation, because ultimately that's the contractual deliverable at the moment. And until that changes, we need to produce 2D documents. So the architectural side of things is very much focused on conceptual design, schematic design, right through to detail design and production detail. Similarly, on the structural side, a lot of parametric capabilities, and we're addressing now structural design in steel, masonry, concrete and timber. And it provides a free design environment which allows free-form structures to be produced, as well as formulaic standard steel or concrete frames. So the examples on the right-hand side, as a project from Ramble in the UK, you can see there very specific concrete frame to that particular building. Linking to analysis software as well is really important, whether it's our own applications or whether it's third-party applications. The ability to integrate the engineers with the technicians that produce typically the BIM models. It's about round-tripping that data and reaching out to do the detailing work, whether that's rebar or steel work detailing. From a mechanical point of view, again, it's a fully embraced, fully featured design, 3D design environment from which documentation is produced, allowing the engineer to work in plan or elevation or isometric or any combination which makes sense to them as an individual. But again, like in the structural discipline, it's about linking out to other analysis and design tools. Again, whether it's Bentley's own applications, the HeaverComp product line, for example, or whether it be through to third-party, utilizing GBXML as a link through to a large number of third-party applications. So, in terms of the subject of BIM, there are lots of technology pieces that need to be linked together. We talk about collaboration within the industry, but collaboration between software applications is really important as well. And finally, the electrical discipline, this is addressing power distribution, lighting, fire alarm systems, emergency lighting systems, telecommunication systems within a building. And again, likewise, links to other design tools is an essential part of the discipline. Now, there are, from a design point of view, there are other techniques and other technologies which play an important role. One of which is computational design, the ability to parametrically design a scheme. An example here is the Francis Crick Institute in London, which was actually, interestingly, the lead design organisation used Revit, but the fabricators, the architects that designed the fabric of the building used the Bentley MicroStation and generative components. And generative components is our computational design technology, which is integrated completely with EcoSim Building Designer. I'm not going to spend too much time on the AVIs, but just to illustrate very briefly the capability of a tool like GC and how it integrates within the design. So at an early stage, an architect can use this tool to produce a concept or a schematic at a very early stage, but this is an intelligent schematic. So we can start to tweak and twist and change the profile of the facade in this particular example, explore different design iterations, and then integrate that back into the main design modeling exercise. These tools are really powerful to the architect or to the structural engineer, and wouldn't be used necessarily to design the whole building, but with certain aspects of the building. Now, the issue in terms of collaboration, model review is an important task. Now, that's a task, an activity that takes place amongst the design team, but when the contractor's on board, that might be from the early stages or comes on later, that design review activity is really important. So providing tools to assist that process is essential. Visualization, well, I think most applications today have got very powerful visualization capabilities. Our Luxology rendering engine is capable of producing very, very high quality visualizations, both for the expert, but integrating into the core design team as well. And one challenge within a design model is the coordination of detailed information. I'm just going to let this AVI run while I talk. And details at 1 to 5 or 1 to 1 are not modelled in the 3D design, in the BIM model. That's a misperception. To actually model a building of this scale and size, which is a large hospital project, it is physically impossible to design and model that to 1 to 1. So that's where the details, two-dimensional details, come into play. And one of the key requirements in the context of BIM is being able to display that detailed information in the context of the model where it physically exists or refers to, and the ability to switch on additional detail from that document. But the important thing and the clever thing with hypermodeling within the Bentley platform is linking all of that information dynamically. Now, it doesn't stop at just detailed drawings, but specification documents as well can be linked into this workflow. I'm not going to have time to play that entire video. I'm just going to move on. Quantities, as the model's built, information about quantities is there, and that can be passed on to cost estimation systems at the appropriate stage, and that's an activity typically within a contractor domain or within the QS domain if it's a separate organization. Other tools which are embedded now in EcoSim, solar analysis for shadow generation or for calculating the solar exposure of the building in its context on site. Point clouds. Now, point clouds are a very, very powerful means by which information can be gathered from an existing site situation. So I've got a very good example. This is from the Crossrail project, which is From a client point of view, this is one project where the client is savvy enough to understand what they can gain from adopting a BIM workflow. And this is just one example. This is Paddington Station, where a number of point clouds were collected. You can see the tripods as we move through the video here. But it's how a design organization can utilize this data in the context of designing with that information. So this is providing a backdrop, very, very useful set of data, provides all the contextual data, but EcoSim Building Designer can interact directly with that point cloud data, and now we're producing design geometry of this particular doorway, for example. Now, just to wrap up my session, I just want to talk about what is BIM from a Bentley perspective. And we all know the acronym stands for Building Information Modeling, and from our point of view, it's quite misleading in terms of what that's referring to. A lot of people think the modeling term relates to 3D modeling. So from our point of view, it's about collecting information, and that information needs to be managed. And also, as we move forward, the relevance of mobile technology is becoming really, really important, particularly in the contractor domain. And field applications are what we're focused on, and delivering capability to tablet devices, portable devices that can be used in the field to collect information, verify information, and feed information back to the main system. So it's about producing, ultimately, an integrated, intelligent infrastructure model. So we go through the normal design, workflow, design, build, operate, and from a client perspective, what they're really interested in is integrating that building design as a one-off building, perhaps, or it's a collection of buildings. Think of Crossrail, that is a collection of buildings and infrastructure. So it's really important from their point of view to integrate that information with the virtual world that they need to manage and operate with on a day-to-day basis. So this is where, it's interesting, David was talking about the geographers. Geographers play a really key part in the process of BIM. And there's a correlation between BIM and GIS from our perspective. So land use data or infrastructure data can all be integrated into this model. Transport data, whatever information, it needs to exist on a similar coordinate system, and all of that can be collected and integrated together. And this is where Crossrail, projects like Crossrail, gain benefit from having all of this information integrated into one single environment. It's not one single database or one single model, by the way. It's a collection of federated models which are all interrelated together. I've seen this diagram many times. It's the government technology ramp. From our point of view, we're addressing each of the disciplines, and it's not just about building. It's about civil engineering, it's about GIS, all integrated together. So we have the discipline-specific applications, but in terms of managing information in a BIM context, it's providing a managed environment. And ProjectWise is our technology that integrates all of the information together, providing the project team as a whole access to a single source of truth, and that's really essential on any project. And then from a client, owner, operator point of view, it's how we distill that information that's been collected through design and through construction into what becomes an asset model. And that's what's really important from a client point of view. So is that 1 minute, Alan? Yes. Yeah, okay. So I'm just going to skip forward to talk about the concept of the I model, and I just want to put this into context in terms of reviewing information from a typical team there of whatever disciplines, whatever technology they're using, produce a composite model for review purposes, and that's what we call an I model. And an I model is really important in terms of providing integration from different software tools, authored information, into one model for review purposes. From a BIM coordinator's perspective, using our tool Bentley Navigator, that information can be reviewed, clash detection can be performed, and schedule simulation can be performed, and so on. But wouldn't it be great from a client point of view if we can embed all of that intelligent BIM information into a PDF document? Then all that's needed is simply Acrobat Reader So we've embedded an iModel into a PDF document. An iModel contains the geometry and the business data, regardless of its source. And from a client point of view, as I say, all they need is Adobe Acrobat Reader, and they can view the information. They can look at not just the geometry or the documents, but all of the business data that's being collected along the way. I talked about mobile applications. Just to briefly mention those, ProjectWise Explorer, Bentley Navigator and Structural Synchronizer, all available as free downloads from the Apple App Store.
Okay.
And then just to finish, just to mention about interoperability. Interoperability is absolutely key in terms of sharing information from one platform to another. And our commitment to interoperability, that white paper can be downloaded if you've got, if you want to know more.
Thanks, Neville.
And just thanks, Suzanne. Just one final point, if I may, Alan.
Yeah.
If you want to know more about the subject that I've talked about today in terms of EcoSim Building Designer, we're holding an event on Friday in our Dublin office. Information's in the pack on your desks, but please talk to Kieran or Tony or Randall out of the stand if you want to attend.
Okay. Neville, thank you very much. Thank you. It's our appreciation.